All right, so we are going to be doing the airplane lab for the next 2-3 days or so. And what's the first thing we start with during a scientific investigation? Research question. Good. Research question. So on your investigation sheets, research question. This is going to be your research question. And how do we write it again?
How does blank affect blank?
How does blank affect blank? Good. So what we're going to do is how does the type of paper, or I'm sorry, the mass of paper affect how far it flies, the paper airplane. How far the paper airplane flies. So please write that down on your sheet now.
Is the white piece of paper or the blue one?
The one that says planning and investigation. Yes, sir.
Scouts.
Yes. Same scouts as last time.
No.
Okay, so it'll be you and you. All right. So please make sure you write down that research question. That's the question that's guiding our entire investigation. How does the mass of the paper affect how far the paper airplane flies? So let's get that down. Now, I want you to make a hypothesis. You're going to make your own. How do we write a hypothesis? Who can tell me? Yeah.
If, then, because.
If, then, because. Good. What comes after the if?
Then.
No. What goes in the blank after the if?
The IV, independent
We
variable.
talk about, what about the independent variable?
The condition.
The condition. What's the independent variable like right now? So, the mass of the paper airplane. So you might say, if the paper airplane has more mass, or if the paper airplane has less mass, then what do you talk about after the then?
Effect on the dependent variable.
Yeah, the effect on the dependent variable. So what would happen to the dependent variable, how far it flies, if the mass is greater or if the mass is less? And then after the because comes the what?
The line, the explanation.
Yeah, the why, the explanation. So you write down your explanation. Please take a few minutes to do that now. Please write down your hypothesis.
Do we have to do if the airplane weighs less, or can we do it if it
It's not weight, it's mass. The difference between mass and weight,
Oh,
so like this roll of tape here, it has the same amount of mass whether it's on the moon or the earth. There's the same amount of stuff in this roll of tape, no matter where it is. But it's going to weigh differently whether it's on Earth or whether it's on the moon. Weight is just how much it's being pulled on. Mass is how much stuff there is in something. That's the difference. So, go ahead and write a hypothesis, something like, if the mass of the paper airplane is greater or less, then it will fly farther or not as far. Because, and then give your explanation why you think that's going to be. There, sir.
Are we allowed to work with our partners or just alone?
You're working with your table partner.
Okay.
Shh, you need to be writing right now, though. Okay, so when you're done with your hypothesis, you're going to want to write this down in your material list. You're going to need one 8.5 by 11 inch piece of copy paper, one 8.5 by 11 inch piece of construction paper, one meter stick, and one metric scale. I'll give these to you guys in a few minutes.
Okay.
And now I just want you to watch this carefully for a second, okay? So, everyone take a look at this paper here. I gave you guys construction paper and copy paper, but what do you notice?
That
Yeah, the construction paper is bigger than the copy paper. So that would be not one variable between the papers, one being a different type of paper than the other, but that would be two variables. One's a different material and one's a different size. So what we're going to do to remove that other variable is we're going to cut down the construction paper to be the same size as the copy paper. So if you want, you can either trace around the copy paper or just cut around it, but make sure that they're the same size. Go ahead and do that as soon as you're ready. So you're just cutting along the copy paper, just like that. And then cut along the other direction, so that way your two pieces of paper are the same size. Bam. Now they're the same size. Make sure that your material lists are filled out also, please.
Just push it back. Okay, push it back. Push it back. Push it.
What if it's not exactly perfect, like it's just a teeny bit off?
Get it as close as you can, but if it's a teeny bit off, that's okay. If we had like a grant from Harvard or something, then we could get it super exact, but we're okay. And once you have both pieces of paper at the same size, please have your table group holding up like this so I know that you're all ready to go, because I'm going to show you how to fold them next. Thank you, sir, for holding them both up. Appreciate that. I'm sorry? Yeah. Good. See some of you guys holding those up. Thank you for that. I appreciate that. Very patriotic. Yes. Yes, sir.
For the scouts, does it have to be one boy and one girl?
No. Just you're working with your table partner, whoever that
Yeah,
is.
but like the scouts.
Oh, the scouts? Not today. We're not worried about it. Looks good. Is there anyone still working on getting their papers to be the same size? Okay, cool. All right, now I'm going to show you how to fold the papers. One person's going to fold the construction paper, one person's going to fold the regular paper. And I'm going to do it up against the whiteboard here so it's easier to see. Everybody ready?
I don't have anyone.
First thing, you're going to fold it in half hot dog style. Fold it in half hot dog style. We're all folding it the same way. That way we have as few variables different as possible. That way we're keeping them the same.
Are we doing the color paper? Yeah.
One's doing colored paper, one's doing the copy paper. They're going to be folded the exact same way. So you're folding it once hot dog style.
Yeah.
It's playing like this.
After that, you're going to fold one triangle down to the fold like this, and the other triangle down to the fold like that. Just get it as nice and neat and as close as you can. You're going to do that. So you should have that now. Kind of looks like a house. When you're done with that, you're going to take your airplane, you're going to fold it in like this. Okay? And you're going to fold it one time so that this flat edge here goes flat to this edge here. So just watch for a second. You're going to fold it so this flat part here goes to this flat part here. So the flat edge that was up here, we folded it down so it's flat with this one. And then we're going to do that same kind of thing one more time. Fold it so it's flat, like that, all the way down. Huh? And then you do the same thing to the other side. You go flat against it like this. And I'll come around and help you fold if you're confused in a minute. And then you fold it flat one more time. And you should have an airplane that looks like this. You just need to fold it one more time. I'll show you in a minute. So let me show you one more time with the white paper now. I'm going to show you one more time with the white paper. So pay attention. You fold it hot dog style. And then you fold it into the crease like this, so you got a little house. And then you fold it like this. Now this is the part that confuses people, so pay attention. You're going to take this flat part and put it against this flat part like this. And then you're going to do that same thing one more time. Okay? So you're going to take this part, this flat part, and put it flat against that part one more time. Like that. It's making a little more sense now? Yeah, you do it twice. So, flat to flat, like this. And then flat to flat one more time. There we go. I'll help you fold in just a minute, okay? I want to go on. I'll come back and help you guys in just a second. I want to go through this process though to make sure we understand what's happening. So now you have two paper airplanes. They're folded the same way. They're the same size. What's the only difference? What's our independent variable?
The mass.
The mass. What's different is the mass, and that's what we're going to do next. No, it's okay. I got it. So now, everyone take a look. No, just leave it. It's fine. I'll edit it later. So now back here, what you're going to do, your group is going to come back here. It's going to put the airplanes on the different scales here, and you're going to write down how many grams each airplane weighs. And I say weight, but it's really the mass. So what's the mass of each airplane? In my case, the regular paper is 5 grams, the construction paper is 7 grams. Yours might be slightly different, but it's probably going to be pretty close. Just make sure you write that down, record those numbers on your paper somewhere. I'm going to explain to you the procedure that we're going to follow. So you should be writing this down in your procedure section. What you're going to do is you're going to take each airplane and you're going to take turns throwing it and you're going to measure the distance. So if I throw the regular airplane first, I throw it, and then using the meter side, the metric side, you're going to measure how many meters it is to the airplane. So 1 meter, 2 meters, let's say 3 meters. I go, okay, there's one. So I threw the normal one time, now I'm going to throw the other one. And then I'm going to measure again. 1 meter, 2 meters. Okay? I'm going to throw each airplane 10 times and measure how far they fly. So after this, I would throw the normal one again, and then the construction paper again, and then the normal one again, and the construction again. You're going to throw each one 10 times, and you're going to record how far each one goes. And then after that, you're going to graph the average flight for each different type of plane. Does this make sense?
Yes.
Are there any questions?
No.
Yeah.
So do we just make our plane and then throw them 10 times for the measure?
You're gonna throw the normal one, then the construction paper, normal construction paper, back and forth, and measure how far it goes each time.
What do you want us to record on?
I want you to record it on the back of your papers. There's an area that says data table. I want you to make a data table there and record how far each one goes. Yeah.
Shouldn't you put your name on it? So if you throw
Yes. Yeah. Put your name on it, but that's it.
put your name on it.
Just put your name on it, and that's it. So that's how you're going to run the experiment. Then when you're done recording it, you're going to make a graph, and then you're going to write your RDDO conclusions. That, ladies and gentlemen, is the airplane lab. Go ahead and stop there.